Hi and welcome to the Bare Basics. Today we're going to have a look at transformation of non-linear functions, something that I know freaks out a lot of students, but once you've got the basics down, there's really no need to worry. Alright, so let's begin by looking at what is a non-linear function. Well, if you're in Year 11, you're probably calling these functions. If you are in Year 10 or below, you're probably still referring to them as equations. So in this sense, the term function and equation are interchangeable, all right? So for a nonlinear function or equation, it does not graph to a straight line. So in this case, it means that the degree of the variables, so that's the powers, are either higher than 1 or less than 1, but never 1, because if the variable or if the power was 1, it would be a straight line. So it helps if you can recognize the basic form of the most common nonlinear functions, because that will have you one step ahead in the problems. So let's have a look. Let's begin with the quadratic function. It has the general equation of f of x is equal to x squared or y equals x squared. So here the power is 2. The shape is a parabola. And you can see in the example that we've got there, it goes through the origin, because when x is 0, x squared, so 0 squared equals 0, so y equals 0. Hence it's symmetrical about the y-axis, and they're the major properties of a parabola. Okay, stepping it up, so we're now going to look at a power of 3, and we have the cubic equation. So the general equation is f of x equals x cubed. So let's just have a quick look at this graph. So when x is equal to -1, -1 cubed will be -1, so our coordinate will be -1, -1. When x equals -2, -2 cubed is -8, so our coordinate will be -2, -8. So you can see that we're all on the in the negative, so in the third quarter there. Then we have something called the point of inflection. That's where our graph changes from having a negative coordinate to positive. So when we have x equals 0, y will equal 0, so it goes through the origin. And when x is equal to +1, y will equal +1. When x equals +2, y will equal +8. So we have that curve that's there. Our next one we'll look at is the absolute value function. It has a really distinctive V shape, and our general equation is the f of x is the absolute value of x. So, as I said, it's a V shape. The y value is always positive because our absolute value is magnitude. So that is always positive because there's no direction to it. So, as I said, it's got that really distinctive V shape. And the final one that we'll look at is a reciprocal function. Now, with a reciprocal function, it means the larger the x value, the smaller the y value is going to be, and vice versa. So the general equation of that is f of x is equal to a on x. Now, when x is equal to 0, we are left with a on 0 is equal to f of x, and of course we can't divide by 0, so f of x at that point is undefined. That means that we are left with an asymptote of when x is 0, that becomes our asymptote. So what it means is that our line will get very, very close to the y-axis, but it won't actually touch it. And it actually works that way with the x-axis as well. So they're called asymptotes because it comes very, very close. So it has asymptotes at x equals 0 and y equals 0. Now the function that I've just put up in front of you looks really scary, and I would not hesitate to say that some people are freaking out at this point. But there's no need to, because it's actually very simple once we break it down. If you let a equal 1, and at this stage h and k both equal 0, what you have is the general form of the equations that we just looked at. When n equals 2, we have f of x is equal to x squared, so that is our quadratic. When n equals 3, we have f of x is equal to x cubed, so that is our cubic function. So what this actually is the equation we can use to transform any nonlinear function, and that is a function where n does not equal 0 or 1, because if that was the case, they would be linear. So let's break it down and see how we can make sense of that jumbled alphabet soup that is in front of you there. Okay, so the first thing we're going to talk about is dilation of nonlinear functions. So we're talking about stretching the function. So we've got our equation there, that's the one that allows us to transform functions. And in this case, we're going to look specifically at the letter A, because A is what we call the dilation factor. If A is larger than 1, it makes the graph of the function longer and skinnier. So I have a teaching aid here. It's a loom band that's nicely been done by my daughter. So if this loom band represents your function, and we want to increase the value of A and dilate it, it means that we're going to make it bigger. And as we make it bigger to lengthen it, you can see that our graph, or our loom band in this case, gets longer and skinnier. So that's what happens when you make A larger. Now the reverse of that, when you make A smaller than 1, because if it's 1 it stays the same, so if you make it smaller than that, it will make it shorter and fatter. Okay, so what that means is if A is smaller than 1, it makes the graph of the function shorter and fatter. Now you've seen that with the loom band. Let's see what it looks like actually on a graph. And the red line here is our original graph, and the blue line is the graph that has been stretched a little bit. So in this case, A is greater than 1 because it has grown and it is stretched out. So once again, our loom band comes out and it's stretched out. And so it is longer and a little bit skinnier than before. The last thing to think about with A is if it is negative, then the graph will actually be reflected. So the A is able to do two things. It can make our graph longer or shorter, but it can also make it reflected as well. So let's go on to the translation of functions, and that is sliding to the left, right, up or down. So we start off with our equation again. Now think about it. If you have an x value and you substitute it into the equation, then you're going to get your y value. So the way we can change the y value is to change k. So we change the y coordinate to move the graph up and down, and we do that by putting k in. So if k is positive, it's going to make our y value larger, so it's going to move it up. And if it is negative, it's going to make our y value smaller, so it's going to move it down. And there's the summary of that. So that k changes the y value. Now, if we want to change or slide our graph left or right, that affects the x-axis. So we have to change the x-coordinate. And that is done by adjusting h. So if h is positive, it moves the graph to the right. And this is because our general form is minus something. And if it's negative, it moves to the left. Now, this kind of seems counterintuitive. So a rough rule of thumb is if it's negative, so if we've got x minus h, so it moves to the right, it moves towards the positive. If it's x plus h, then it moves to the left. So just think of it as the rough rule is whatever the sign is, then move it to the opposite side. Okay, and that's the same for any nonlinear functions. So let's have a look at what that means on the graph. So here our original function of f of x is equal to x squared is shown in black. So when we've done our transformations of x minus 2 all squared, so that means we're moving 2 to the right along the x-axis, and then we have a plus 2 in the k value, so that means that we are moving up. All right, well, in a nutshell, that was transformations of nonlinear equations. If you have any questions, just ask me in class, or you can email me at my Ed Queensland email address there. So I hope that today's lesson has made you understand a little bit more about, or helped you to understand a little more about transformation of non-linear functions, and has gone a small way of making maths more bearable for you.